All right. Good morning, students. I hope now video clarity and voice and everything is good. I hope once check and inform to me. Check and inform to me whether it is clarity is good or not. So if everything is fine, then we'll go back again to the class. Okay. Okay, I think everything is fine. So fastly comment on the comment section so that I get to know now. Firstly comment. Let us solve the sixth problem on this now. I'm not coming from anyone. Wait 1 minute, I'll check any comments are there here. So I did not get any comments. Okay. Okay, all clear said by some students. Okay, let me start now because my comments are not getting here. So let me go for sixth problem. We complete today. Our aim is we need to complete up to 15. Okay. Actually, I thought I want to give for you all homework, but not required. Let me solve for you all. Okay. All right. So now first sixth question. Find all the points of discontinuity of f where f of x is equal to 2x plus 3 and 2x minus 3 if x is less than or equal to 0, less than or equal to 2, if x is greater than 2. This is the given actually yesterday was explained. So that is shortcut method. But now which I am going to explain is how you need to write in your examination. Okay. So now according to examination point of view, how to write check now first. First, they will not mention that x is equal to 1 or 2 or 3 or nothing is mentioned. So such kind of time what we need to do is let C, K, B, L, any alphabet you can take, and that has a real number you have to take. So I'm thinking let C be any real number. So I'm taking C as any real number. According to the question, in which places I have to check whether I have to check for the continuity. So first one it is C is less than 2. And next, C is equal to 2. Next, C is greater than 2. These conditions I want to check first. So what are those? C is less than 2, C is equal to 2, C is greater than 2. So such kind of thing. What is your continuity? Okay. So if you want to check that, what we need to do is first. So first case number 1. So your case number 1 is C is less than 2. So for that, what we need to do, what is your f of x? So less than 2 is nothing but 2x plus 3. So right here, f of x is equal to 2x plus 3. Okay. So then f of c is equal to 2c plus 3. This is equation number 1. And next, limit x tends to c, limit x tends to c, f of x. Remember, c is nothing but less than 2 in our take. So less than 2 is nothing but what is your for that is f of x 2x plus 3 only. So now limit x tends to c 2x plus 3. Now when you remove the limit, we will write that as 2c plus 3. So wherever x is there, substitute c. So now after completion of this gives us equation number 2. Then say now from 1 and 2, these both are equal. The first condition, which was the first that method, that small method which is there, that is proved. So that this is continuous at x is less than 2. So how to write this? Just check carefully now. F of c is equal to limit x tends to c f of x. Therefore, here I am writing, therefore, f of x is continuous for all real numbers less than 2. So now first condition is finished. Now let us go for second condition. Second condition is what? C is equal to 2. So now case 2, it is C is equal to 2. So C is equal to 2 means how to solve them? Whenever equal to 2 is happening, that is nothing but x is nothing but 2. So equal to 2x plus 3 here. So right here, f of x is equal to 2x plus 3. So then f of 2 is equal to 2 into 2 plus 3. That is 4 plus 3. That is nothing but 7. Equation number 1. See, like this, any number is given, then you have to find for 2 minus and 2 plus also. Then only it is complete answer will happen. Otherwise, it is not possible. So now for that, what we do first? Limit x tends to minus f of x, and here limit x tends to 2 plus f of x. So now 2 minus what is your function? 2x plus 3. So now write limit x tends to 2 minus f of x means it is 2x plus 3. So now after that, here limit x tends to 2 plus 2x. See, whenever greater than 2 is happened, 2x minus 3. So write 2x minus 3. Just substitute wherever x is there 2. So now here substitute 2 into 2 plus 3. 4 plus 3 is 7. Equation number 2. Next one. 2 into 2 minus 3. 4 minus 3 is nothing but 1. So this is equation number 3. Now you observe carefully in this 1, 2, 3, which we can say that are not equal. So we can say that left hand limit is not equal to the right hand limit. Therefore, it is continuous or not continuous at c is equal to 2 or x is equal to 2. So you can comment on it so that I get to know whether it is continuous or not continuous. Tell to me your answer. So somebody comment on the comment section so that I get to know that not continuous sent by Vinod. Very good. Clap for Vinod. Vinod was sending nicely. Very good. So now we can write here it is therefore LHL is not equal to RHL. This is from 1, 2 and 3. So at last we write here, therefore, f of x is not continuous at x is equal to 2. So now two cases completed. Last case is what? C is greater than 2. Same like this method only you have to solve. Let me solve here. I hope you all written this and I'll solve here. C is greater than 2 now. So let me write here case number 3, C is greater than 2. So whenever C is greater than 2, what is our f of x? C is greater than 2 means 2x minus 3. So now write here 2x minus 3. Then f of C is equal to 2c minus 3. Then limit x tends to c, f of x is equal to here. X tends to c means greater than 2. That is the meaning because here c is greater than 2. So now greater than 2 means what is function? 2x minus 3. So now limit x tends to c, 2x minus 3. So now that is equal to limit. Anyhow, when you remove the limit, what we need to do? Substitute wherever x is there, c. So now 2c minus 3. So that is equation number 1. Equation number 2. Right. Therefore, from 1 and 2, we'll write here f of c is equal to limit x tends to c f of x. Therefore, f of x is continuous at so that I cannot write. So continuous for all real numbers, all real numbers less than greater than 2. So right here because here greater than 2. So at last what we can conclude? So first we said that in case number 1, so we said f of x is continuous for all real numbers less than 2. And second case we found that it is discontinuous at x is equal to 2. Third case we found that f of x is continuous for all real numbers greater than 2 we found. Now at last what we conclude now? So whether this whole function is continuous or not continuous, or what we can conclude at last. So last step you have to write something. What is that last step? I can write. So conclude now. So Vinod, you can conclude, or Kusum can conclude, Sahil you can conclude, or Kushi Paul is there means you can conclude. Anyone can conclude. Who is going to conclude first? Let me know. Firstly, tell to me. So for me, yes, sweat is more and more. Complete fast and comment on the comment section firstly. Who is going to comment first? Let me see. All right, fast. Sahil, firstly tell to me what we conclude at last. I hope so you are unable to conclude. So let me conclude myself. Just concentrate here. Therefore, we'll write f of x is discontinuous only at x is equal to 2. That you have to write. Okay. So what we need to write at last conclusion? Therefore, f of x is discontinuous only at x is equal to 2. So except at x is equal to 2, remaining all places it is continuous. Okay. That's all about your 6th problem. Let us go for our 7th problem now. So now little fastly I'll explain, just concentrate only on the board. So 7th is this wonderful question, 7th one. So 7th one, f of x is equal to modulus of x plus 3 if x is less than or equal to minus 3. Another one minus 2x if minus 3 is less than x is less than 3. Next 6x plus 2 if x is greater than or equal to 3. These are the conditions they were given. So how to solve, just concentrate so that you can understand. Otherwise, it is highly impossible to understand for you all. Okay? Can I solve now? Right. So I hope so. You are saying that just solve. Okay. So now just concentrate now. So how to solve this problem? So this is what they given. So according to last question, you all know that how we solve. So you just concentrate how to solve now. So now first solution, let let. So now I'll write let C be any real number. So two cases, and third case is this complete, that is minus 3 less than x is less than 3. That means in between minus 3 to 3 is there, means what is the function? Function is continuous or not continuous. So after completion of this, what is there? So then it is x is equal to 3, x is greater than 3. That means here not x, it is c, because we thought here c is a solution. So here let me write as C. So now how many conditions we got? One, case 2, case 3, case 4, case 5. So total 5 cases are there, and each case what is your answer we have to discuss now. So let me check now case number 1. C, right, if C is less than minus 3. So when C is less than minus 3, what is going to be your function? So let us write here, it is now f of C, and okay, first I'll write f of x. F of x is equal to, it is less than symbol came. Whenever less than happened in the modulus, I hope you all remember this modulus x function. Let me write here modulus x is equal to, that x minus x when x is less than 0. So then 0 when x is equal to 0, and x when x is greater than 0, right? So that means if it is less than happen, what I need to write? Minus x. So now, so here it is, we need to write, instead of modulus x, we need to write minus x plus 3. Clear now? I hope you all understood. Because of the modulus, we are writing here, instead of modulus x, we are writing minus x, because it is less than. So now what we'll do here is just find now f of c. F of c is equal to minus c plus 3. So this gives us equation number 1. Then limit x tends to c, f of x. Limit x tends to c. What is your f of x? You know that minus x plus 3. Write that minus x. When you are removing this limit, wherever x is there, substitute c now. So now we'll write here minus c plus 3. Equation number 2. So at last, what we'll write here? From 1 and 2, f of c is equal to limit x tends to c, f of x. Therefore, f of c is continuous for all less than minus 3. So this is, so now let us go for second case and third cases also, then you can understand 2. So what is case number 2? If c is equal to minus 3. So right here, if c is equal to minus 3. When c is equal to minus 3 happens, what possibilities are there? Minus x plus minus 3 plus 3. So you get as 3 plus 3 is equal to 6. This is again equation number 2. Now right hand limit we have to check. So can you rub there? again for your loading problem. All right, do one thing now. Today we'll stop your class. Just go through the solutions. If you are having any doubt, you can ask me within the evening. Okay. All right. May God bless you all. So I hope this connection problem is more today. So we'll. All right.